Now here's where the story gets genuinely strange. When you run a computation that takes 10 septillion years on classical hardware in under 5 minutes on quantum hardware, you have to ask a question that makes physicists deeply uncomfortable. Where is the computation actually happening? On a classical computer, the answer is simple. It happens in the transistors, in the chips, in the circuits right in front of you. Every step of the calculation has a physical location. Every operation leaves a traceable path through the hardware. On Willow, the answer is not so clean. Random circuit sampling works by running a quantum circuit, a sequence of quantum operations across all available qubits simultaneously. The circuit is deliberately randomized, which makes it nearly impossible for classical hardware to simulate, because a classical computer has to track every possible outcome one at a time. The number of possible states grows exponentially with each qubit added. At 105 qubits, the number of possible states Willow could occupy simultaneously is a figure with over 30 digits. Frontier, the most powerful classical supercomputer ever built, housed at Oak Ridge National Laboratory in Tennessee, capable of over a quintillion calculations per second, cannot keep up. Not because it's slow, because the problem space is so vast that no classical architecture, no matter how fast, can navigate it within any time frame that has human meaning. Willow navigated it in the time it takes to drink a cup of coffee. Some physicists, including David Deutsch, one of the founding theorists of quantum computing, have seriously argued that quantum computers perform parts of their calculations in parallel universes, in other branches of reality, under the many worlds interpretation of quantum mechanics. The argument is straightforward. If the computation isn't happening here, in the physical qubits we can see and measure, then it has to be happening somewhere. And quantum mechanics, taken seriously, says that somewhere is other branches of the universal wave function. Google's team didn't make this claim publicly, but they didn't have a tidy alternative explanation either. What they had was a result, a correct result, verified independently, reproduced across multiple experimental runs, a computation that finished in under 5 minutes and that no other machine on Earth could replicate in any timeline that connects to human existence. The computation happened somewhere. The answer came back correct, and the path it took to get there is not something our current physics can fully trace. That gap between the output we can verify and the process we cannot is not a minor technical footnote. It is a genuine open question in fundamental physics.